Okay, so it says before reading the STEMScopedia, complete the before reading activity on the left side of your interactive notebook. So what you're gonna do is just kind of scan through here, and I want you to find at least 3 words that you are just not sure about. You don't know them yet. So me just scanning through here, I picked volcanism, obsidian, and crystallize. You don't have to do the same 3 words that I did. And if you have more than 3, then do that. But I want you to pause this video and spend a few minutes just glancing through the STEM scopes and come up with 3 words, and you're going to put them where it says words I don't know yet. And then after you pick them, you're going to write what you think they might mean. So put your own definition, what you think they might mean. It's okay if you're wrong. So pause this video and get that top part of your left-hand page done. Pick 3 words that you don't know. You can pick more than 3, but pick at least 3 words that you're not sure about. And then you are going to write your own definitions for them. All right, so now let's go to the STEMScopedia. And then it says whenever you reach a stop and jot question in the STEMScopedia, you're going to stop and you're going to write the answer on the right-hand page. Okay, think about it. Think about a rock at a riverbank, the water cascading over it. Ooh, cascading. Maybe that's a word that you don't know yet. Flowing water seems gentle and soft, but over time, it can make rocks undergo changes, such as becoming more rounded in shape. How does water help form and change rock? And is that the only way rocks change, or are there other ways? Think about it. How can water help form and change rocks? Can rocks change by other means? 3 types of rock. Have you ever had a rock collection? Chances are that if you have, you collected rocks that look different from one another. Some may be solid colored, while others could have stripes or other bits of rocks and minerals cemented within them. Perhaps some are flat and flaky. Geological processes constantly happening on Earth can cause rocks to change. There are 3 main types of rock, and each can be identified by the results of the process that forms it. Rocks are made of different types of mineral grains held together. Various processes change rock structures, which in turn change the way they appear. The rock cycle is the cycle through which Earth's rocks change from one type into another over time due to various Earth processes. It creates changes in mineral compositions and physical structures. It is called a rock cycle because rocks are made and destroyed at every part of the cycle. There's no real beginning or end to a rock's existence. The diagram below shows the full rock cycle. We will look at 3 parts of this cycle separately. Volcanism, or volcanic eruptions, form and change rocks by heating and cooling massive amounts of material. Erosion and weathering usually happen from wind, water, and ice, and can cause sediments and small rock pieces to break off from the main rock. Sedimentation can cause layers of material to form into rocks, sometimes trapping fossils of dead organisms inside. These processes can change any kind of rock into any other type of rock. Material is constantly being recycled through the processes that drive the rock cycle. Vocabulary. Rock cycle. The cycle through which Earth's rocks change from one type into another over time due to various Earth processes. It creates changes in mineral compositions and physical structures. Igneous rock. Let's look at each of the three types of rock, beginning with igneous. The diagram below highlights the part of the rock cycle involved in the formation of magma and igneous rock. You can see that igneous rock forms from magma. The presence of igneous rock in a landscape indicates volcanic activity, either currently or in the past. Igneous rocks form deep inside Earth. All igneous rocks have crystals that are formed when molten lava or magma cools, but these crystals are different sizes. The speed at which the lava or magma cools determines the crystal size in any given igneous rock. If the rock cools quickly, crystals within the rock do not have as much time to form. When the molten rock cools slowly, it can result in large crystals. These are two samples of obsidian, also known as volcanic glass. Both were formed from magma that cooled. The sample on the left was formed from magma that cooled too quickly for the rock to form crystals. The sample on the right formed from lava that cooled very slowly, so large crystals formed. Other igneous rocks, like pumice, show remnants of bubbles formed when the water and gas from the volcanic eruption become trapped in fast cooling rock. This results in the lightweight rock that is useful for abrasive products used for scrubbing, such as toothpaste, cleaning stones, and rubber erasers. It is also used to make concrete. Igneous rocks can be further classified by their mineral compositions. One group consists of light-colored, less dense minerals like quartz and feldspar. Another group is made of darker, more dense minerals such as olivine. Two additional igneous rock groups have different combinations of minerals than the previous two groups. Granite is a common igneous rock that is abundant, and because of that, frequently used in building materials such as countertops, tiles, and floors. The kitchen in the picture below has granite countertops and floors. Granite is a strong rock that gets its color variations from different minerals that are in each rock sample. Feldspar can make granite pink, and quartz can make the sample appear white or clear. Biotite and muscovite can make granite appear green, dark brown, or black. Basalt is another common igneous rock. It is usually dark and dense without large crystals. The ocean floor is made of basalt. It forms when lava erupts through underwater volcanoes or cracks, or in the oceanic crust and solidifies quickly under the cool ocean water. It is commonly used in home insulation and decorative rock. Basalt samples can look slightly different from one another based on how long it took the rock to cool. The world's ocean floors are made of basalt. Vocabulary: igneous rock. Rock formed when lava or magma cools, forms crystals, and solidifies. Lava, molten rock or magma that has reached Earth's surface by volcanic action. Magma, melted or molten rock material beneath the Earth's surface, cools slowly to form rocks with larger crystals. Melting, when a sample of matter changes from a solid to a liquid. Number 2 on your right-hand page. Are you more likely to find an igneous rock in a river or at the base of a mountain? Why? So you can pause the video to answer that question. Sedimentary rock. Weathering, erosion, deposition, and cementation are the main ways that sedimentary rock are created. Sedimentary rocks are made of sand, dirt, rock pieces, and dead organisms. They form when particles of other rocks are deposited in layers and cemented together. The diagram below shows the part of the rock cycle that focuses on sedimentary rock. So it shows you how igneous rock becomes sediment, metamorphic rock becomes sediment, and how they become sedimentary rock. Some sedimentary rocks are made from rock fragments that have been worn down by wind, water, or ice. Others contain organic materials like the remnants of organisms that died. Other sedimentary rocks are made of precipitates that are left after water evaporates from a solution, such as in a cave. This sedimentary rock consists of sediments, or small bits of rock containing the remains of a once living organism. When scientists conduct fossil digs, they must use tools to gently separate the fossil remains from the surrounding sediments and rock. Sedimentary rocks are the only ones that are created on top of Earth instead of inside. The first step in sedimentary rock formation is weathering, where rocks are broken into smaller pieces by wind, water, ice, or gravity. Weathering is a very slow process that usually happens over hundreds or thousands of years. Sediments can range in size from a grain of sand to a boulder. Sediments that form rocks are usually small and can easily be picked up by moving wind or water, which drops sediments in place like riverbeds or swamps. Erosion and deposition from wind and water helped create these rock formations. The next step is compaction, when rock particles or sediments are pressed together or packed down. This can happen by gravity and the pressure of other layers of rock as more and more sediment are deposited in the same area. This extremely slow process takes millions of years, so the sediments are in the upper layers are being added by the same processes as time passes. The weight of those sediments causes the ones underneath to squeeze together. After more time passes, the compacted sediments stick together and turn into rock during a process called cementation. During cementation, spaces in between the rocks or sediments called pores fill with groundwater, natural gas, or oil. They can also fill with minerals that act as cement, while other minerals crystallize. Common examples of sedimentary rock include limestone and sandstone. Limestone consists of calcite and makes up about 10% of the Earth's crust. Sandstone is mostly quartz, which makes it look beige or tan. It can contain feldspar, which makes it look pink. If a sample also contains iron, it may look red. This sedimentary rock formation in California's Death Valley National Park contains various minerals in its layers. Note the effect of erosion on the rock formation as well. Many of the eroded sediments from this formation will be deposited in other places and may reform into new sedimentary rocks. Most sedimentary rocks can be identified by their layered appearance. Some types have smaller rocks embedded within them, such as breccia in the center of the image below. Vocabulary: sedimentary rock. Rocks form when particles of other rocks are deposited in layers and cemented together. Weathering: the mechanical or chemical process by which gravity, water, and wind and ice break rocks into smaller pieces. Sediment: each material that is broken down by the process of weathering can be eroded and deposited by the agents of water, wind, ice, and gravity. Compaction: when rock particles or sediments are pressed together or packed down by gravity and the pressure of the overlying rock layers. Think about it. What are 3 factors that can affect the appearance of sedimentary rocks? Pause the video and answer that question. Metamorphic rock. Some rocks look like sedimentary rocks because they have layers, but they are wavy. These rocks are actually called metamorphic rocks. Metamorphic rocks are rocks that have changed from another type of rock. The prefix meta means to change, and the root morphous means to form. They have formed deep underground and have changed because of the intense heat and pressure inside Earth. Pressure is a force exerted on matter through contact with other matter. This process itself is called metamorphism. This rock formation in Greece shows a curved, wavy layers common in rocks that have undergone metamorphosis. Both igneous and sedimentary rocks can become metamorphic rocks if they undergo changes deep within the earth. Metamorphic rocks can also change into other metamorphic rocks. So, you have igneous rock turning into metamorphic, so the temperature and the pressure. You have heat and pressure, metamorphic, sedimentary, heat and pressure, metamorphic. The main difference between igneous and metamorphic rocks is that when igneous rock forms, the crystals melt. When the rock changes its texture and composition without the crystals melting, it is classified as metamorphic. Metamorphic rocks do not get as hot as igneous rocks that melt during their transformation. Many metamorphic rocks have their crystals arranged in bands that may look like stripes. Common minerals in metamorphic rocks include calcite, mica, and quartz. The mineral grains in metamorphic rocks sometimes align in different ways to create various patterns. They can be found in areas of high tectonic activity, such as near mountain ranges, areas of volcanic activity, and other places where geological processes cause high pressures and temperatures to change rocks. These samples show the many variations that metamorphic rocks have. Metamorphic rocks undergo intense heat and pressure to change them. They do not get as hot as to melt like igneous rocks do. Vocabulary. Metamorphic rock. Rock formed deep underground due to the heat and pressure. Pressure, a force exerted on matter through contact with other matter. It affects melting and boiling points. Think about it. If you found a rock while on a hike, what clues might tell you that it is a metamorphic rock? Pause the video and answer the question on the right. Scientists in the spotlight. Anna Jones Stoss, U.S. Geological Survey. Anna Jonas Stoss was one of the first geologists to work for the United States Geological Survey. She named many geological formations in the eastern United States and studied rock formations in that area. Her first published paper discussed the rocks in the Appalachian Mountains, and throughout her life, she traced the origins of many rock formations. She was the first person to discover the rocks and formations that indicate a huge crustal fault extending from Virginia to Alabama. Most of her ideas were not recognized as correct until long after her death, since during her lifetime, most women did not enjoy the same respect as their male peers. The image shows the side of a rock formation in the Appalachian Mountains in the eastern United States. The big picture. Rocks can change through geological processes in the rock cycle, such as volcanism, heat and pressure within Earth, and weathering and erosion. Igneous rocks form from melted rock called magma and crystallize. Sedimentary rocks form from deposition and compaction of sediments that cemented into new rock, sometimes trapping the remains of dead organisms inside, forming fossils. Metamorphic rocks and rocks of any type, including other metamorphic rocks that have been heated and undergone pressures that caused them to change but did not get hot enough to melt completely before reforming. Connect it. What are some processes that form and change rocks? The geological processes that change rocks are all around us and happen constantly. From active volcanoes to crashing waves, many processes form and change rock around the world. Wind and water change rocks by weathering them and eroding small sediments. Volcanism and other tectonic activities involving lava and magma change rocks by heating them near or above their melting point. Rocks are constantly changing into other types of rocks through the rock cycle and will continue to do so.